Hi everybody, it's Miss Austin. I'm going to be doing the Unit 6, Lesson 6 practice problems. Number 1, it says, suppose a classmate missed the lessons on completing the square to find the center and radius of a circle. Explain the process to them. If it helps, use a problem you've already done as an example. So let's go get one from the book today. Let's explain it one more time. I am going to get the one maybe from the lesson summary. That might be a good one to do. Let's say you had x squared minus 4x plus y squared plus 6y equals 3. So from our previous work, we know that there's two trinomials on this left-hand side. So I'm going to leave some space. So this came from x squared minus 4x. There was another number here, plus y squared plus 6y, another number, equals 3. Okay? Now, we know the center of a circle looks like this. So we need to figure out what number was here that made this a perfect square trinomial. So sometimes you can do the box to work backwards, like this. You know this is x times x, and you know this came from combining these two. So that's exactly broken in half, -2 and -2. Well, what's -2 times -2? That would make a +4. That was the number that was missing right here. Right? But what do I want to rewrite it as the equation of a circle? I want to know what the half of that was. So this is -2. Now you might think, well, who cares about that number? Well, look, if you're going to add 4 to the left side of the equation, you got to add 4 over here to keep the equation balanced. Got to follow your rules of algebra. Okay, now that can be rewritten like that. Now I can see the x-coordinate for the center. The center of this circle is 2 something. Now how do I figure out this one? Maybe you think about the box, or you just do it in your head. Half of 6 is 3. 3 squared is 9. That's the number that goes here to make it a perfect square. So the number that would go in here, what was the half of that? The 3. But if you add 9 over here, you got to add 9 over here. So now I can see the center was 2, and since that's positive, it means it was a negative. And then the radius, let's add, what do we have here? 7 plus 9 is 16. So then you want to rewrite that as some number squared, or you just, what's the square root of 16? 4. You could also write that as 4 squared if you wanted. Okay? All right, number 2, match each expression with the value needed to make it a perfect square. So we're kind of doing what we did up here. If I want this to be a perfect square, I'll do 1 with a box. I know x times x made x squared. If it's a perfect square, this number's got to be the same. So you cut that in half, -4 and -4. That'd be -4x and -4x, which makes -8x. Now, why do I make the box? Because now I can see that if I multiply those two, this is the number that I need. That would make it complete. So this needs to be 16. Now, how can you do it without the box? What's half of -8? -4. Square it, you get 16. All right, let's do that here. What's half of 20? 10. What's 10 squared? 100. What's half of -16? -8. What's -8 squared? +64. What's half of 9? Hey, this is 4.5. And 4.5 squared is 20.25. I feel like the student book, maybe not, had a different problem, but nope. Find the center and radius of the circle represented by this equation here. Let's take a look. Okay, so we go x squared plus 4x, leave some space, plus y squared minus 10y. Now we got to move the 20 over here. How am I going to move that? Using my rules of algebra, I'm going to minus 20. Now I'm going to do what I was doing here. What's half of 4? 2. What's 2 squared? 4. So I'm going to add 4. then I got to add it over here. What's half of 10? Negative. We'll worry about that in a second. And 5 squared is 25. These numbers that you add will always be positive, because even if that's negative, when you square a negative, you get a positive. So now I got to add 25 over here. All right, now let's rewrite it. So this would be what? X, half of that, plus 2, plus y, half of that. Here's where your minus comes into play. Equals, this would be what? 5 plus 4 is 9. But 9 can be rewritten as 3 squared. Why do I want to write it like that? Because I can see the radius. You can put 9 if you want. So now I know the center is -2, -5, and the radius is 3. Select all the expressions that can be factored into a squared binomial. How would we know? Well, when we take the half of the middle and we square it, do we get the last term? Right? What's half of 2? 1. What's 1 squared? 1. Yes. What's half of 5? Now this one, I know, scary. They did it as a fraction. Half of 5 is 5 halves. And what's 5 halves squared? Square the top, square the bottom. Yep. What's half of -10? -5. What's -5 squared? No, it should be 25. No. What's half of -10? -5. What's -5 squared? 25. What's half of +10? 5. What's 5 squared? Yes. What's half of 20? 10. What's 10 squared? Number 5. An equation of a circle is given by x plus 3 squared plus y minus 9 squared equals 5 squared. Apply the distributive property to the squared binomials and rearrange the equation so that one side is equal to 0. So I'm going to multiply. I'm going to remind you, how do you multiply this? You can either, remember this is x plus 3 times x plus 3. Some students just think this is x squared plus 9. Incorrect. You can also use a box to do this if you want. X times x is x squared, 3x, 9. Combine those two. So this is x squared plus 6x plus 9. This one, I'll do the other way. Y minus 9 times y minus 9. Y times y is y squared, -9y, -9y, plus 81. There's those middle terms. So that makes y squared minus 18y plus 81 equals, they got 5 squared here, which is 25. They want me to get everything on one side so that one side is equal to 0. So I'm going to minus the 25. Now, who does that 25 get combined with? I'm going to combine all these regular numbers. Combine like terms. So now we have x squared plus 6x plus y squared minus 18y is 9 plus 81 plus, oops, was it minus 25? Yep. 65. That's another way to write the equation of a circle. Number 6, graph the circle given by this equation, right? So now we know our center is -1, 3, and what's the square root of 16? 4. So -1, 1, 2, 3. I should have maybe went by 2's, but oh well. I'll just add a couple of. Okay, so radius of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. The circle. Find the distance from the center of the circle to each of the points. So we're going to do this point 2 minus 1. Oh, here, let's plot this. 2, 1. 1, 2, 1. What's the distance from here? Let's just remind ourselves how we do this. If I want to find that distance, I make a triangle. So that's 2, and this is 1, 2, 3. And I would do the Pythagorean theorem, right? And how could I have found that? I could have done x minus 2, the x coordinate minus 2, and the x coordinate minus 3. And no, I said that the first time. I'm just going to do Pythagorean theorem here and find the distance. Here we go. So 2 squared is 4, plus 3 squared is 9, equals, I don't know, squared. So 13 equals x squared. What's the square root of 13? Distance is approximately 3.61. Now do the same thing. 4, 1. 1, 2, 3, 4, 1. Now I want to find this distance. So it's 2 and 1, 2, 3, 4, 5. So I'm running out of room here, but 2 squared is 4, plus 5 squared is 25, equals, I don't know, squared. 29 is the distance. What's the square root of 29? About 5.4. And then 3, 3, 1, 2, 3, 1, 2, 3. Need that distance. Well, wait a sec. That's perfectly from the center. I can count it. 1, 2, 3, 4. What do these distances tell you about whether each point is on the inside or outside of the circle? Well, we know the radius is 4. So when the distance is less than the radius, like A, that means it's on the inside of the circle. So make a little chart here. When the distance is less than the radius, the point is inside. When the distance is greater than the radius, like this one, I got 5.4, see it here? Then the point is on the outside of the circle. And if the distance equals the radius, like this one, then I know it's on the circle. And if the distance is equal to the radius, then the point is on the circle. All right, last one, number 7, because we were skipping number 8. We didn't do this lesson. The triangle whose vertices are 3, -1, 2, 4, and 5, 1 is transformed by the rule xy becomes 2x, 5y. Is the image similar or congruent to the original figure? Well, first of all, when you multiply the x and the y by something, if you multiply by the same amount, that's a dilation, which produces a similar figure. But here, the x's have been multiplied by 2, and the y's have been multiplied by 5. So that is not a dilation. So that would not be similar or congruent. See. I hope that helped, and I'll see you soon.